Okay, here's lesson 25. It's workbook pages 257, 258. Okay, kind of how we'll do this is I will read through the question with you and help you understand the graph. Then I'd like for you to pause the video and see what you can do to figure it out on your own. Then come back and I will go over the answers. Okay, so let's take a look at number 1. We are going to find the distance between points L and M. Okay, find the distance between L and M. So I notice that L is right here and M is right here. Then find the distance between points L and N. Okay, so then find the points or the distance between L and N. Okay, which distance is greater? How much greater? So if you'll notice, there's quite a few things that we need to do here. So let's go ahead and start working with our picture and make sure we know where to start. So find the distance between points L and M. Okay, so the first thing I'm going to do is I want to find this distance. So I'm going to draw a line here because I want to know that distance. And I notice that since my line is diagonal, I can't just count the boxes. So I'm going to have another method, and that method is the Pythagorean Theorem that we've been learning. Okay, next we need to find the distance between points L and N. So the next one we would need to do is this one right here. So you always use a straight edge, it helps you. Okay, so I have what would be the hypotenuse of two different right triangles. Now remember, we talked about this in the last lesson. In order to use Pythagorean theorem, we do need a right triangle. So I'm going to look at ML first. How can I create a right triangle that uses ML as the hypotenuse? Now remember, we can do that by either sketching a right triangle below, or we can sketch one above. So I'm going to go ahead and sketch this one above. So notice that I can actually join those 2 points. So I'm going to take my line and go horizontally until I reach my line that I'm taking vertical. So notice that since this is on a grid, and these lines are perpendicular, this is a right angle. So now I do get to use Pythagorean theorem. Now, one of the easiest ways to do this is to go ahead and just count your sides. So I'm going to let you work on that. And notice that here with this triangle, we also need a right triangle. Now notice this one is actually a little bit different. So it's long and skinny. So I am going to draw a line going this way and this way. So again, notice that our hypotenuse is the diagonal, and because of these grid lines, this is my right angle. So this is a good time to go ahead and pause and try to figure out what is the length of both of these hypotenuses. I don't know if that's the right way to say it, plural. And then which one has the greater distance. So pause and see what you figure out, then come back and I'll go through the answers. Okay, so you should have already tried something. You should have something written on your paper. The first one I'm going to try to do is the LM. Now, remember, that's going to be a squared plus b squared equals c squared. Let me count my legs. 1, 2, 3. And then I have 1, 2, 3, 4. Oh, that looks so awesome. I love when I see legs that are 3 and 4 because I get to go to my Pythagorean triples. Remember, we talked about this in the last video. So notice that I have legs 3 and 4. So without doing all the math, I already know what the hypotenuse is. It is 5. Okay, so I know that C is going to be 5 because I was a smart mathematician and I used what I know about patterns to save myself some work. Okay, now what about our LN? LN. Okay, again, a squared plus b squared equals c squared. It's always good to write it just so we remember it. Here's leg A, B. Remember, you can use those interchangeably. A is going to be 1, 2, 3, 4, 5, 6, right? 1, 2, 3, 4, 5, 6. I even have my glasses on. Okay, 6 squared. And B is only 1. Okay, so now I've got 6 squared is 36, plus 1 squared is 1, is c squared. So 36, oops, plus 1 is 37. 37 equals c squared. So the square root of 37, square root of, so c is, now I go back to my chart here, since 37 is not a perfect square, I notice that it is actually between 36 and 49, right? Because it's 37. So that means it's a little over 6. So it is going to be probably about 6.1. I should not have equal signs there. I am going to do about, because it's not exact. I didn't use a calculator, but I'm estimating. So now remember, let's go back and find out what questions we have to answer. Which distance is greater? Definitely ln, because it's 6.1, and 6.1 is greater than 5. How much greater? Remember, they're asking you to compare them, and what's the difference? So I would do 6.1 minus 5 gets 1.1. I'm trying to think about what we're talking about. I don't even know what our unit is. I guess so it's 1.1 units larger, right? So ln is 1.1 units larger. Okay, I realize, I hope you guys could see that. I didn't move it up. So if you need to pause and take a look at what I have, go ahead and do that. Okay, let's talk about number 2. Again, we'll get started. I want you to pause and try it on your own, and then come back and see the work. Which point has a distance of the square root of 5 units from the origin? Point A, point B, point C, point D. Okay, so if we started here, which one has a distance of the square root of 5? Which of these? I'm kind of hand sketching. Okay, well, remembering the square root of 5, the square root of 5 is going to be somewhere between 2 and 3. In fact, it's going to be pretty close to 2, right? So what I have to look at is do some type of comparison. Go ahead and pause right now and find the best way you can figure out the square root of 5. Which one of these lines has a square root of 5? Okay, if you're back, let's go ahead and take a look. How can we narrow this down? So knowing that we have a square root of 5, so I have to have an a squared plus a b squared that equals the square root of 5, right? Wait a minute, no, that would actually be 5. That's right. Okay, so let's look at point A. Point A has 1, 2, 3, 4, and 1, 2, 3. Okay, so in that one, in A, I'm just going to write really small here. So we would have 3 squared plus 4 squared equals, well, we already know. Do you guys recognize that one? 3, 4, 5. So A has a distance of 5. So the distance is not the square root of 5, so it's not A. How about B? Let's look at B. Here's B. B is 1, 2, so 2 squared plus 1, 2, 2 squared. So 4 plus 4 equals c squared. So I get 8 equals c squared. So the square root of 8 equals c. Is that what we're looking for? Nope, we're looking for the square root of 5. So it's not B. Okay, let's look at point C. Point C. Okay, I'm making it kind of messy here, but we'll try. Okay, so A is 1, so 1 squared plus 1, 2, 2 squared. Okay, so 1, oops, that was supposed to be a 1, plus 2 times 2 is 4, equals c squared. So now I do have 5 equals c squared. So square root of 5, or c squared. So c equals the square root of 5. Is that what we're looking for? It is. So it is actually C. Okay, so now that we know that the answer is C, we notice that Ken chose A as the correct answer. How did he get that answer? So is Ken correct or incorrect? Ken was incorrect. And if you'll notice, when he did the work, he probably, remember A squared plus B squared equals C squared. He plugged in the 3 squared and the 4 squared. And he got 9 plus 16 equals C squared. And he ended up getting 25 equals C squared. So when he found the square roots, he found out that 5 equaled C, but he thought 5 is the same thing as 5 squared. Or no, sorry, the square root of 5 is the same thing as 5. So he got confused on that. So go ahead and explain that in your own words. Okay, let's look at number 3. What is the distance from point X to point Y? How could you figure that out? Go ahead and pause the video for a minute. Start to solve it on your own, then come back and take a look at the answers. Okay, so now that you're back, you should have a line connecting X and Y. You should also have noticed that you needed to draw some type of triangle, right triangle, so that you could count your lengths of your sides. So let's go ahead and do that. Okay, now remember the distance of a diagonal is usually going to be our hypotenuse. That is our C. I'm going to label this as A and this one as B. Now I can go ahead and just count my edges, some of the lengths of my sides. I've got 1, 2, 3, 4, 5, 6. A is 6. B is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, make sure I counted that right. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so now I notice that I do have my Pythagorean theorem. It is a right triangle. So I'm going to plug in 6 for A. I'm going to plug in 10 for B. And it's going to equal C squared. Okay, so now you should have had 36 plus 100 equals C squared. 136. Find the square root of each one. Finding the square root of 136, I would take a look at my chart. Oh, look at that. I don't even have to do the work. That's already a solution. So notice that C is the square root of 136. So it is not A, B, or C, but we have the answer D. Okay, let's work on number 4. Segment PQ is one leg of isosceles triangle PQR. Okay, do you remember what an isosceles triangle is? Isosceles triangles have two sides that are the same length. So in an isosceles triangle, if this length is 5, then this one also has to be 5. If this one is 10, then this one has to be 10. So what this problem is telling us is that PQR is an isosceles triangle. So we have PQ, and since PQ is this length, then that means its other side has to be the same length. Okay, so let's go ahead and start working on this. Part A, name a point R in quadrant 4 that could be the third vertex of the isosceles triangle. Okay, there were a lot of big words in there. Let's go back and take a look at this. Name a point R. Okay, that's our job. That's what we have to do. In quadrant 4. Now, just in case you don't remember, this is quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4. So they want us to name a point in quadrant 4. So I need to put a point here somewhere. That could be the third vertex. Now remember our vertex? That is going to be, it's like another word for corner or angle. Okay, so it's going to be the other point of the isosceles triangle. So I need to make a point R over here that makes up the third angle or the third corner of our triangle. and draw the point on the coordinate plane. Okay, so remember what we said about isosceles. Has to be the same length. So think about what you've learned about transformations, right? So in an isosceles triangle, we are actually just going to end up doing a flip so that we make sure we're going to do a reflection, okay, over this line of symmetry right here. So I'm going to actually just reflect it over so that it makes the exact same length. Now, to help me do that, I notice that my point here is 1, 2, 3 points away from my line of symmetry. So that means my new point is going to be 3 units to the right side. So 1, 2, 3. Right? Did I count that? 1, 2, 3. Okay. So my point is here, because notice that my triangle. Okay. So I'm going to go ahead and erase that. Let's go ahead and draw that leg in there, or not that other side. Okay. So notice now that my two lines are exactly the same length. And at this point, you get to go ahead and explain how we just did that. Okay, pause your video. You can explain in your own words how we just drew that other side of the triangle. Okay, now part B. What are the side lengths of the triangle to the nearest tenth of a unit? What is the perimeter of the triangle to the nearest tenth of a unit? Okay, notice two questions. So I've got to answer two things. What are the side lengths? And what is the perimeter? Okay, so at this point, see what you can figure out on your own first. Then if you need to, come back and we'll go over an answer. Okay, let's look at what you did about the side lengths first. Now, in order to find a side length of this triangle, notice that it's diagonal. That means I can't just count units. I need to use Pythagorean Theorem to figure it out. I'm going to sketch that line of symmetry back in, because notice that as of right now, I don't have a right angle. I don't have a right triangle. I need to create them. So there's a couple of ways that you can do this. You can go ahead and create your triangle up this way, or you can actually draw it down the middle of our triangle. Okay, do you notice I have two right triangles, right? I have one right here and I have one right here. Notice that if I find the information for this triangle, it is going to be the same information for this triangle. That's the cool thing about isosceles triangles, and you're actually going to learn a lot more about that once you hit 9th grade. So let's go ahead and look at what we do know. So did you figure out the side length of the triangle? Okay, I'm going to focus on this triangle, because if I find this triangle's hypotenuse, I will then find this triangle's hypotenuse. So I'm going to start with my equation, a squared. That was my puppy dog hitting the chair. Okay, so right triangle, remember, our right angle here points to our hypotenuse. That's what we don't know, so I leave that c squared. Now here's A, right? 1, 2, 3. So A is 3. And B, there we go, 1, 2, 3, 4, 5, 6. This sounds familiar. Didn't we just do that on the other side? Maybe it was on the last page. Okay. Anyways, I thought that looked familiar. Okay, how do we figure out this number? Okay, 3 squared. 3 times 3 is 9. 6 squared is 36 equals c squared. Okay, now 9 plus 36 is 45 equals c squared. So c, remember we have to find the square root. That's why I remember it. I've already done this on my calculator just so that I could be ready. Can you guys see okay? I realized that my light, let me close my blinds. There we go. That help? That should be a much clearer picture. Okay, so square root of 45 is going to be somewhere between 6 and 7. In fact, I used my calculator a little bit earlier, and I realized that C is 6.7. What do we do with that information? What did we just find? Think about that. Notice in my triangle, I just found my hypotenuse, 6.7. Okay. Now, the cool thing about isosceles triangles, if this is 6.7, what is this length? Remember, we made this length to be the exact same as this length. And we actually have two of the exact same triangles here. Remember, we actually did a reflection. So that means these two are congruent. So if this is 6.7, then this is 6.7. Okay. So now I know this length is 6.7 and this length is 6.7. Did we answer the first question? What are the side lengths of the triangle to the nearest tenth of a unit? Yes, we did. It's 6.7. Now, second question, what is the perimeter of the triangle to the nearest tenth of a unit? Perimeter. Anyone remember what perimeter is? Okay, perimeter is around the shape. So what that means is the perimeter of a triangle is side 1 plus side 2 plus side 3. So I need to add up my 3 sides in order to figure out the perimeter of the triangle. Now, which triangle do you think they're talking about? They are still talking about the isosceles triangle. Remember, they had us draw this. We only sketched in these to figure out measurements, but they still want to know our isosceles triangle. Okay, so let's go ahead and take a look. What is side 1? It doesn't matter what you name what. We've got 6.7 plus 6.7 because it's the same. And what is the length of our third side? That would be the base here. We've got 1, 2, 3, 4, 5, 6. Okay, if we add that all together, I'm going to add a 6 plus a 6 plus a 6 is 18. My 0.7, so I have 7/10 and 7/10 is going to be 1.4. So I'm putting that together as 19.4, 19 and 4/10. So 19 and 4/10 units is the perimeter. Now, make sure that you are able to explain this if you need to watch the video again so that you can really see all the work. Go ahead and do that. I'm going to send these videos to you guys. If you guys want to Zoom and talk more about this, I'm available. Good luck.